two-way table and the part B. And the part B. Yeah, I can say that.
Wesley, your picture.
No Lindsay today.
Dude, actually, no, I was a badass freshman year.
You say that about everything.
What did you say?
I learned yesterday I had a sister in class.
Really?
She was so awesome.
And then there's Wesley.
And then there's Wesley. That's okay. I give Nolan the same trouble. Because Brooke was much cooler than Nolan.
Oh yeah, I bet she was.
She was.
Oh yeah. Totally.
I had her 2 years.
You got me 2 years though, huh?
What?
You only get me 1 year.
I only get you 1 year.
I'm pretty sad about that, huh?
Brooke and I were like this. I had her in honors pre-calc, and then I had her in AP stats, and she was my aide.
Oh my gosh. I know you guys talked about friends, you said.
We did talk about friends. Because your last name's Geller.
Yeah.
Like Monica and Ross.
That made me laugh. She got so excited.
I love Friends.
Yeah, I know. I can go.
Dude, Friends is so unfunny. That's. I don't like those,
So are you.
like those
So are
every
you.
time anything happens, we're like.
They recorded, no, they recorded in front of a live audience.
That's not true.
Yeah, it is. Look it up.
Oh, is it?
I'd be sad if I did it, like, if I was in there, you'd, like, see the stage and shit.
There's no way that people would laugh at that much.
Yeah, if you read,
No, above the stage it says laugh or something. Oh, no, it tells
if you like read anything like Joey and Chandler,
Yeah,
they would
I
try
agree
different
with
jokes
Wesley on here.
because they wanted to see which joke the audience would actually laugh at more.
Oh, that's.
So it was a real reaction. You're corny.
Yeah, she got you there.
I did. Thank you. All right. Venn diagram, if you prefer that one, although most of you made the two-way table. And then Seth did answer the question for us. We know they read the New York Times, so what's the probability they read USA Today? The ones in the denominators cancel out, and you get 0.05 divided by 0.25, which is 0.2. Yes, ma'am.
Why did we use 1 instead of 0.25?
Say that louder for me.
Why did we use 1 instead of 0.25?
He did use 0.25. We have 0.05 divided by 0.25. He just did the fraction over the fraction. Yeah. All right. We're going to learn a new rule today and a new strategy. We have Venn diagrams, two-way tables, simulations, and now we're going to draw trees.
Yay!
Yeah, sure, like a Christmas tree. No, it looks nothing. I'll draw it in green, but it looks nothing like. And I'll put the numbers in red.
Yeah, they're like little lights.
Oh, I don't think I have red. I don't think I have red. Can I use pink? Is that okay?
Hold on. Wait.
Hold on, I might have a red in my new pens. I do. I was just saving them until my old pens ran out, but just for the sake of Christmas trees.
We're just talking about Christmas colors. Green and then red.
I got a brand new red out because you were hesitant about pink, and now you're like, whatever, I don't care.
Well, no, I said no, red's fine. Like, that's what you said. Okay,
I said pink. Is pink fine?
And then I said.
All right.
Okay.
Wesley, will you read for me, please?
A computer company makes desktop and laptop computers at factories in 3 states: California, Texas, and New York, the California factory produces 40% of the company's computers. The Texas factory makes 25%, and the remaining 35% are manufactured in New York. Of the computers made in California, 75% are laptops. Of those made in Texas and New York, 70 and 50% respectively are laptops. All computers are first shipped to a distribution center in Missouri before being sent out to the stores. Suppose we select a computer at random from the distribution center.
Thank you, sir. So we're going to construct a tree diagram to represent the situation, and then we're going to find the probability that the computer is a laptop. So with tree diagrams, they tend to have a word to start them off. The word does not matter, okay? But since we're going to eventually figure out about laptops and desktops, and it says select a computer, I'm going to use the word computer. Can we read that color? This is, I'm using what closest to brown I could have, so it's the stump of my tree, my Christmas tree. So the computers are made in 3 states. They're made in California, Texas, and New York. So from computer, we're going to have 3 branches to show those 3 locations. California, Texas, New York. Oh, you really were going to ask me if we write things out? Like,
No, I was asking if you were going to make us write it out, like on tests and stuff.
as long as I can understand your abbreviations, use abbreviations. So, of the computers that are produced in California, we have 40%. So along the branch, we're going to put 0.4 for 40%. We have 25% are made in Texas, so on that branch we put 0.25. And then New York has the remaining 35. Then it tells us that the computers made in California, 75% are laptop, and the other type they make are desktops. So for each state, we're going to have 2 branches. California is going to have 2 branches. Texas will have 2 branches. And New York will also have 2 branches. I'm going to use L to mean laptop and D to mean desktop. So we have laptops and desktops made in each state. %75% from California are laptops, which means what percent are desktops? Do we say 35?
No.
Or am I just hearing things?
I just heard a 7, so I said 30.
Oh, okay. 25.
75.
Then it tells us Texas and New York make 70 and 50% laptops respectively. So Texas makes 70% laptops, which would mean 30% desktops. And New York is half and half, 50% laptops, 50% desktops. Then we put one last branch from each of them. And at the end of those branches, we're going to find the probability the computer was made in California and it's a laptop by multiplying these 2 numbers. So 0.4 times 0.75. Might help if I have a calculator. 0.4 times 0.75, 0.3. So this is 0.3. Probability California, and it's a desktop, That one's 0.1, right? And then Texas laptop, that'd be 0.175. Texas desktop, that's 0.075.
But is this like the percentage of all the?
Yes. New York laptop, 0.35 times 0.5, which is 0.175. And that would be the same for the desktops. And like Wesley was saying, is this the percent of all? Yes, it is. If we add these numbers together, we should get 1. So let's just double check really quick. 0.3 plus 0.1 plus 0.175 plus 0.075 plus 1.75 plus 1.75. And we get 1. And like I said, the way we read these, as we were following the first branch, that tells us California, and then the L tells us laptop. So if you were asked to find the probability that a computer came from California and was a laptop, you would just follow the branches, California laptop, and we get 0.3 at the end. Question 2 says, find the probability that the computer is a laptop. So we just want to find the, sorry, my pen was weird, probability of L. Doesn't specify what state the laptop comes from, so that could be a California laptop, a New York laptop, or a Texas laptop. So we're just going to look at all the L's. So we have 0.3, 0.175, and 0.175. And we're going to add those three numbers together to get the probability that a randomly picked computer is a laptop. That would be, that's 35.3, so 0.65. And this pen is slowly dying on me. Questions? No? All right, you guys are going to try the next one. Kiana hits the snooze bar on her alarm clock on 60% of school days. If she doesn't hit the snooze bar, there is a 0.9 probability that she makes it to class on time. However, if she hits the snooze bar, there is only a 0.7 probability that she makes it to class on time. On a randomly chosen day, what is the probability that Kiana is late for class? So you're going to create a tree diagram. And then please do not forget to answer this question. You can try the bottom question if you want, but we haven't totally talked about that one yet, but you can try it if you would like to. Oh, shh.
What is this? Good vibes. Let's put this sticker on the
No, because I'm almost done.
Oh, that's true.
And I don't want to.
Just put it on the water bottle.
I was thinking I'd take it home and let Molly put it on her water bottle.
Oh, yeah. She would love
Oh, that banana is not ready yet.
Why?
Maybe it's getting
That was devastating.
It looks a little green at first.
No, it's not.
He's colorblind.
There's supposed to be some brown dots on it for optimal flavor.
There literally
it does have better
is.
flavor.
Why are you judging my banana?
It's banana shaming.
I love that we all Wesley shame in this class.
Yeah,
It
Wesley,
just
get
makes
out.
it so much. No, don't tell him to leave.
Too far.
I didn't mean that.
Joe. Joe didn't look so Wait, I don't get how the snooze bar works. Is it the same amount of minutes every time?
You hit the snooze bar and it doesn't.
Isn't it just a random amount of minutes?
No, it's 9 minutes every time.
Wait,
9 minutes? Damn.
Yeah.
why 9?
Because when Lionel first made alarm clocks, they first made
They only
that
had
it
1
was,
through 9. Or 0
no,
through
it
9.
was it was on with gears, and the gear increments weren't exactly on minutes, so it was like 9.48 minutes or like 10.13 minutes or something like that. So it was like they didn't want it to be like more than 10 minutes, so it'd be as close to 10 without going over 10. They did 9 point whatever. So now, like I looked for the alarm is 9 minutes.
We were just talking about alarm clocks.
You can't just like choose.
You know like the basic alarm clocks now? How annoying that sound is?
I am a nerd.
Oh, that thing
iPhone
works.
default one?
Yeah, it's almost, you know the radar like that's a
Think about switching the
Caleb
phone.
wishes he was
It like gives me like when I get dirty.
It gives me like anxiety. I don't know
Yeah.
why. Like my alarm if I hear it during
like the
the day.
basic alarm sound.
Which one is it?
No, I'm just like, I can't.
This one, do you have an alarm clock? Or use your phone?
I use my phone. I have an alarm clock, but I use my phone. The alarm clock that I have, I can't change the alarm, and it's that annoying. Yeah, it's bad. It wakes up the whole house. So then I
Who's
use
supposed to
my
wake up to that? It's like stress right when you wake up.
Yeah,
I used to have an alarm clock that you can set into the radio, and it.
Oh yeah, that
Like
Oh my
that
god.
song. Yeah, that one's
Why
it.
would you play that? Okay.
If you have an Apple Music, you can just pick these songs. That's actually
Wait, actually.
I think you can pick any song no matter what.
Have you ever set the alarms in like a hotel?
No, have you?
No, just call the front desk and ask for a wake-up call.
I did that at wrestling.
Oh, that's really
Screw those, dude.
They actually do that for you?
Yeah.
I just like wake up on my own. If I'm in a hotel, I'm already gonna wake up by like 7, so.
Why?
Cause like,
I'd rather hear
it's
that
a hotel.
noise.
Someone's bound to wake me up.
No, me and Bill were literally up at 4:30, and then they told us that the bus left at 7.
Why would you guys watch one of those?
Because Toby left us. It's probably wrong, but you know what?
You know, at least we're attempting.
He's airdrop and he's turtle.
Jesus. like, before you edited it, I remember.
Edited it.
Okay.
Edited it.
Oh, yeah. I forget it. We're getting some stuff down. You know what I'm
This is
saying?
I almost won $50.
Yeah, you did.
I was so mad. He bought away from me.
I wore that because they got the wrong size.
He wore his cup.
Yeah. I was so mad.
I was like, he knows better than to wear a crop top. I was like, really doesn't.
No, he doesn't. Because it gets moved to football.
Yeah, they're less.
Virginia's.
No, it's because
So smart. Well, they got a pack of
that.
clothes, and they were just gonna, they were gonna go back
I'm
and
from
get bigger
Texas.
ones, but
Everything we do is weird.
when they were already getting along, why would I put my batteries? It adds to one.
So she's the fault. She
She didn't know better.
Oh, okay, never mind. I thought there was for negatives, and I was like, how do we get negatives?
Now answer the question. Oh man. Oh man.
Did you bring up the old song?
Word froze kids out.
No, I didn't want to say anything about that. He would have been like, I don't even know.
What are the two options for Kiana to do?
Yeah, don't say it.
Don't hit snooze.
Sorry, that what? I feel like you would definitely blame something like me.
Like, sorry, she just didn't want to come to my house.
He never asked me to go to his house. He asked me to come to my house.
Under construction. Or some shit. Sorry, her house was
That's what I do. Like, and then you're wait, okay, you hit snooze and then you're not.
That
Alright. If she hits snooze, what's the next piece of information?
Yeah, that's weird. I do two.
Timer later, right? So from each one you have two more branches on timer.
Sorry, my dad's a teacher.
Yeah, so go for the one where it's she hit the snooze.
If she hits snooze, probability she's on
What? See, I want to know what he gave.
The worst part is that he said that he's like, this pick is bad.
Do you want to know what he gave me? He gave me a cake and said, text
A
me.
cake?
No, listen, this is text me on there, and then he said, this is because always sleeping on the
and then your last branch.
There was no shot that said that. I thought he gave me one of those big ass like heart-shaped gloves.
No. That, it's like, if that isn't a bigger,
They just like wrist you up.
if that isn't a bigger sign that I don't like you.
That's so
Now
bad.
the last one
Who is it?
No one.
4 times 1
No
is
one?
4.
No one.
No.
You go into 7-Eleven with him?
I'm not telling you. No.
And then make sure you answer that.
That's how she does it.
It's fine. Whatever. But then, like, I didn't
Why don't you just tell me you don't like it?
Well, the thing is, I lied.
But you just say, you just walk up to it and say, I don't like it.
I literally told no, and then they commented on my post.
He knew.
He knew I didn't like it.
You don't tell everyone to tell them. Yeah.
Like, go away.
Guys can't take sides.
I don't think I'm thinking he's about love
Guys
yourself.
can't take sides.
It's not even that. It's that weird. Like, yeah, take
Alright.
it.
Write it down, please. Lisa is going to put our tree diagram and answer the question about Kiana being late.
Oh, this is gonna be a lot.
You got this, Lisa. Ouch.
No, that was.
It's supposed to be just a print.
I should have asked him to have a stereo contest.
I feel like he would use that.
Oh no, he would.
Wesley Marie.
What?
Copy down the tree diagram. I can't figure it out. And
Yeah, you're like, it's something.
Ignatius or
Having
something
to
weird
stand
like that.
this little. Do it. Do it now.
Staring contests always like mess up my eye.
Do it, Wesley.
Look at her face.
Do it.
Look at his
Might
face.
make me
You're right, it's funny.
Might make me blink.
I
Oh, you just
blinked.
blinked.
I blinked. I did.
You gotta like, you gotta
wasn't
throw
ready.
stuff at it.
Shaylin just threw me into it. I would have closed my eyes for a while.
Ready?
first.
1, 2, 3. 6 people. Wesley, do it.
I'm telling you to throw things.
See, he went.
Yeah, I saw, but you gotta throw things. It makes sense.
That's me.
It's legal though.
Is it legal?
It is legal.
Wait, no shut, that just works.
It made me laugh. I'm sorry.
Did I put 30 or
You ever sound like make yourself laugh?
36.
You make yourself laugh when you do that stuff?
What?
Like when you make faces, you make yourself laugh?
No, he made me laugh with his stupid piece tongue out.
They wait like halfway through.
And then
But he said that halfway through. He didn't say, he's like,
Wesley Marie.
Marie.
say it like a badass.
Copy.
Yes. Looks like some DNA.
do you want me to figure it?
It starts with an I. Thank you, Lisa. All right, so like I said, this first word or words,
Or urban or something.
that first part does not matter. Do not get stuck on it. If you don't even want to put it there and you just start your tree with nothing there, start your tree. Seth.
What makes everybody treat the word trunk every time?
I don't care. I don't know if on the AP exam if they would. I don't know what they would do because the word doesn't matter. Usually you pick a word that has to do with the problem though. I don't know. Yes, start every tree diagram with trunks. All right. So Kiana hits the snooze bar 60% of the time, which means 40% she doesn't hit the snooze bar. And then I'm going to add, Lisa put not on time, which means this one is on time. And that happens 70% of the time when she hits the snooze bar. 0.6 times 0.7, 0.42. 0.6 times 0.3 is 0.18, so hitting the snooze bar and not being on time. Then we have not hitting the snooze bar and isn't this one? She is on time. Sorry. On time goes right here.
No, that's the answer to the first one.
And then I like how you put not on time and late.
You know what? Maybe we're still not on the same one.
And then we have 0.36 for no snooze bar being on time. No snooze bar and being late happens 4% of the time. So the probability that Kiana is late is 0.18 plus 0.04, which is 0.22.
Oh,
I didn't check everybody's paper, but did anybody try the one on the bottom?
No.
You tried?
didn't get us there.
Are we all wrong? Is that what
Yeah,
that is?
you
Yeah,
are
we
all
all wrong?
They're all wrong. You were right. Annika's gonna put the bottom one on the board for you. Sorry. And then I decided I wanted to sit here either.
Exactly.
I can't remember what. Late or it was 10 once. And I had it to a set at 6. Maggie did not. She had
Yeah.
I was looking over
Really
there.
good search and
Can't
stuff.
see.
She did all.
For both schools? Sports.
Thank you for agreeing.
Yeah.
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 We like
Oh, it's totally wrong.
Oh.
Oh, my hair keeps getting stuck in these chairs and it rips out my hair.
No, it's
No. Just losing hairs every day. Hey, if we just flip our numbers around,
If we just change the whole entire problem.
Yeah.
yeah.
Entire problem.
I was on the right.
Thank you, Annika. All right, so this is a given question. You're told that Kiana is late. Kiana is late for school, so that's our given. We want to figure out the probability she hit the snooze bar if she's late. So Annika gave us our formula. On top is the probability she hit the snooze bar and is late, and then we're going to divide by the probability she's late. Snooze bar and late is this number right here, the 0.18. And then the question you had to answer after you made the tree diagram is the bottom, the probability she's late, whether she hits the snooze bar or not. So 0.18 divided by 0.22 is approximately 0.8182. Questions? All right, now we're gonna create our last rule. Well, not last rule. We have another couple of rules. And then maybe we should update our rule sheet because I've ran out of time the other days, but I think I'll have a little extra time today to update the rule sheet. Did you say no?
No, I said yay.
Yeah, you better say yay. All right. This one says about 55% of high school students participate in a school athletic team at some level, and about 5% of these athletes go on to play on a college team in the NCAA. We're going to use that information to derive our general multiplication rule for the probability of A and B, and then we're going to use it to answer what percent of high school students play a sport in high school and go on to play a sport in the NCAA. All right, so let's start with the information we know. 55% of high school students participate in a school athletic team at some level. So I'm going to define my first event, HS, excuse me, means they play in high school, play sport in high school. So the probability of HS is 0.55 because it tells us 55% participate. The other piece of information that we are given is about 5% of these athletes go on to play on a college team in the NCAA. So my other event, I'm going to just do NCAA, play in college. Now, that underlined statement in pink is not just the probability of NCAA. It's the probability that a student goes on to play in the NCAA given they played in high school, because it tells us about 5% of these athletes. So we're talking about the athletes that played in high school. Now we want to find the probability that you play a sport in high school and go on to play in the NCAA. What do you think they're learning about over there? Sounds like a Western.
Yeah, it sounds like fun.
Sounds kind of like Western. Okay. All right, so we have probability of high school, probability of NCAA given high school, and we want to find the probability of high school and NCAA. What formula do we have so far that uses these three? Let's flip back to what Annika gave us. Snooze bar given late came from snooze bar and late divided by late. So we have a conditional comes from a and divided by just the probability of our condition. So we want to find the and. We're given the conditional and the single for the given condition, so we can rearrange our conditional probability formula to find our general multiplication rule. So since maybe I can fit it in there. I'm going to put it down here since I wrote big here and I want to fit the rule there. So we have the conditional probability rule. So if we were asked to find what's the probability that they play in college given they played in high school, we know that we could find that from taking the probability they played in high school and go on to play in college divided by the probability that they play in high school. So right now we have these two and we want to solve for this top one. So how would I get that top probability isolated by itself? Seth?
You can multiply the one on the left by the denominator.
We're going to multiply by the probability in the denominator. And that's going to cancel it out here, and whatever I do to one side, I have to do to the other side. So to find the probability they play in high school and go on to play in college, it's going to come from multiplying by the probability they played in high school times the probability they play in college given they played in high school. Probability they play in high school, 0.55. Probability they play in college given they played in high school, it's 0.05. I don't know why I put the multiplication symbol in the parentheses, sorry. And 0.55 times 0.05 is 0.0275. So using that to find the probability of A and B, A and B, we took A, the probability of A, times the probability of B given A. We could also do the probability of B times the probability of A given B. Notice whatever is being isolated as just the probability of a single event is our given event. So A would be times B given A. If we're just looking at the probability of B, it's going to be the times the probability of A given B happened. So let's add to our multiplication. our rule sheet. I'll get it up in a minute. If I can find my rule sheet. I know I have it. Here it is. Does anybody need a copy of the rule sheet? That's 5th period's rule sheet.
Do that at home and then
So far, we've, it says rule number 5, but unless you were updating this on your own, the only one we did together was the complement rule. So that was 1, then we need 2, 3, 4, 5. Anybody remember rule 2 or 3? Or 4 or 5? Well, 5 we just did. No? Nobody? I know Jillian does. She did it. You've updated your sheet.
Yep.
Yeah. I just was asking if anybody remembers rules 2 and 3, because it's been a while.
They have
There, right? This one. Rule 2 and rule 3. All right. Rule 2 was the addition rule for mutually exclusive. So to find the probability of A or B, we would just add probability of A plus the probability of B. So this rule name is the addition rule for mutually exclusive.
Wow.
I don't know. I really don't know. He plays lots of interesting things over there. It's Weinberg. Oh, sorry. Didn't want that. No, not yet. All right. Addition rule for mutually exclusive. So this would be for finding the probability of A or B, given that they are mutually exclusive. So that's the key part here, because if they're mutually exclusive, there is no overlap. So we can just add the probability of A plus the probability of B. Now the whole example thingy-mabob, I'll let you fill in. Notes about when to use mutually exclusive. I don't know. That's the key word I would look for. Or disjoint. Where did my pencil go? Oops, sorry. Mutually exclusive, disjoint. Those are keywords you want to look for. Never occur together. So that was rule number 2. Rule number 3 is the general addition rule. That was in the same note packet. So any 2 events, assuming, well, you could use it for mutually exclusive as well. But this is when there is an overlap. We would take the probability of A plus the probability of B minus the overlap, so we don't count those things in the overlap twice. So this one's the general addition rule. General addition rule. any events. And that one tells us the probability of A or B comes from the probability of A plus the probability of B minus the overlap. So the probability of A and B. I don't know what keywords to give you on that one. The general addition rule is when you have an overlap.
So when the two events happen at the same time.
Yeah, but you could use it for mutually exclusive, because if it's mutually exclusive, A and B is 0. So then you end up subtracting nothing. So you could use this for any two events, mutually exclusive or not. This one you can only use when they're mutually exclusive. And then rule number 3, that was our conditional probability rule. Oh no, excuse me, 1, 2, 3. Rule number 4 in the notes. That was the conditional probability rule. So probability of B given A comes from A and B divided by A. Let's see, I haven't used green. Conditional probability. And that tells us the probability of B given A happens comes from the probability of A and B divided by the probability of A. Keywords there would be like given, know that, blah blah happened. And then today we learned rule number 5, the general multiplication rule. Let's go with purple. Where's my purple pen? There it is. So general multiplication rule. That tells us the probability of A and B can be found by taking the probability of A times the probability of B given A happened. Or if you have the probability of B, you would multiply it by the probability of A given B happened. Now notice if we're finding an OR probability, it's addition that we're working with. So these are ORs and we added things. Ands mean multiply. I don't know what keywords to give you for this one either. Tomorrow we'll learn, not tomorrow, there's no school tomorrow for you guys. I get to sit in meetings. And I don't see you Thursday. So Friday, we learn 2 more rules. That's going to fill in the last 2. Another multiplication rule. And then one that technically, like if you look in the textbook, is not a rule, but it shows up often enough that I made it a rule for my class. It does show up. Show up. I don't know how to speak. Alright. I want you guys to go back to the notes, Bianca, and try your exit task. Come on, Nolan, try the exit task while you watch. Oh, there's my good pencil. Scooby, Scooby. Scooby-Doo. My random fun songs. Yeah, and you also didn't put a lot of the other stuff. Bianca. No excuses.
She's gonna go like punch you or something. Oh my god.
Mine hurts back here though, like right under the shoulder.
Right on the exit.
That's your whole, your shoulder is your deltoid. Your deltoid is your entire shoulder.
No, they're like just.
She has 3 parts?
What about the
You have like 3 parts?
trapezius?
That's your
Yeah,
that's a
there's
different
no-
muscle.
Don't you have like 3 deltoid things?
The
You have a rear deltoid,
Oh,
a
front.
lateral
Where's-
deltoid, and a front deltoid.
Where's the trap?
It shows itself here, but then it goes down your entire back to it.
Right. So when I say I have pain right below my shoulder blade, it's my trapezius. She said her deltoid hurt.
That's her
I said
entire
my
shoulder.
trapezius.
So you're right, yeah.
Trapezius.
Your
Thank
deltoid
you.
is your entire shoulder.
Yeah. How do you stretch that muscle?
Do this. It's
No,
short.
that hurts. That hurts.
That's all you're trying to do is short.
That hurts.
Dude.
Do it.
Do this, do this.
Holy.
Did you get your ears pierced?
Yeah.
Wait.
Not here.
You should get a thing in the ear.
Like that.
Here.
Yeah.
Here.
With the cross, yeah.
Here. Only that. It's
Right.
not here.
That
Thank you.
muscle right there. That's your deltoid.
Yeah, I was agreeing with you.
Your deltoid.
Your deltoid, you were correct. My
that's your entire
trapezius is the
shoulder.
one that hurts.
It's not here. That's not your entire shoulder.
Yes, it is.
No, because there's other parts in it.
That's not true.
Yes,
Your
it is.
deltoid toys are a pair of shoulders. Yes, it is.
That is funny.
I'm still hurt. Wait. Damn. Oh my gosh. Wait, how? So I'm an 8?
I don't know. Don't ask me. Ask Miss Berry.
I'm not enrolled in 3 advanced level classes. I'm enrolled in 2.
Did you finish your
I currently have 0 hours of community service.
Yes.
Yeah.
You can just lie, can you?
I'm not torch honors anymore, guys.
Please.
No, don't join torch honors. It's a scam.
You just never realize that?
How can they be mad at me for taking
Be
AP
part of
classes?
the society that does nothing besides get you an extra task. And I suppose it looks good on college resumes.
It does. No, I think no.
Are you gonna know how to do like words that are exciting?
Hold on.
But it'll just be like
What did you get, Nolan?
What do I get for what? The call?
Yeah.
I'm almost there.
You are there.
Oh, I did it?
Yeah.
Oh.
It's one of those four numbers. What are you looking for? Calculator? I don't think you only need one. It's all
.49.
definitions.
Oh, so I don't need the random number.
I give you what you needed.
Oh,
On the side. I give you a number to get the answer.
.49.
Yeah, come do it. Nolan's gonna show you guys the exit task. Okay, Gabe, sorry. Isn't there a website that you can go to? Why? Because you're not going to do a where to cite something like that. This website, like me, you never cite anything, so if I had to record. Anybody good at works cited?
Like, deciding works by hand or with
But by
No,
hand.
go to the-
He's trying to be a good kid and follow
yeah.
directions.
Are you in?
This is called.
Oh, do you not have the paper?
No, I have it done. I just don't know
Well,
how
I
to
just don't know
put
if
it
I
on
did
there.
Go to the library's
Like, not have the packet that you gave us. Got like the So essentially,
well, yeah, but I was like, I feel like this is how we sip it.
Oh,
I keep telling your dad that anytime I'm talking about a class, I feel like when I word everyone's so much smarter, but I don't. Because everybody else makes me feel stupid.
All right.
I hate that when I'm like,
Nolan made a tree diagram.
Thank you.
63% of his first serves stay in. That means 37% of first serves are missed. If his first serve stays in, he wins 0.78% of the time, loses the 0.22% of the time, misses the first serve and wins 0.57, miss the serve and lose the 0.43. The question is about making the first serve and winning the point. So if we just follow our branches, makes the first serve, wins the point, we get 0.4914. Any questions? Okay, well, I don't get to see you for 2 days.